Hello and welcome to today's lesson on elastic potential energy. In today's lesson, we will learn what elastic potential energy is and understand its nature. We will also begin to identify and explain common examples of elastic potential energy in everyday life. So far, we've discussed various forms of energy and how energy can be transformed from one form to another. You've learned the basic principles of energy conservation and how energy manifests in different situations. Building on this foundation, understanding elastic potential energy will enhance our comprehension of physical interactions in everyday life and more complex systems. This knowledge deepens our grasp of energy transformations and prepares us for more advanced topics in physics. Elastic potential energy is a type of energy stored in objects when they are stretched or compressed. It's called elastic because it pertains to materials that can stretch or squash and then return to their original shape. Consider a spring or a rubber band. Both of these objects can store energy when they are deformed. For instance, when you pull back a rubber band, it doesn't move, but you can feel it resisting your pull. This resistance occurs because the rubber band is storing energy as it is stretched. The more you stretch it, the more energy it stores. The term potential signifies that this energy is waiting to be used. It's not currently causing motion, but has the potential to do so. Think of it as hidden energy waiting to be released. In this context, elastic potential energy is the energy stored in the deformation of an elastic object. When you release a stretched rubber band, the stored elastic potential energy is converted to kinetic energy, causing the rubber band to snap back to its original shape. This conversion of energy is what makes the rubber band move. Let's look at some common examples to better understand elastic potential energy. Compressing or stretching a spring stores elastic potential energy. When the force is removed, the spring returns to its original shape, releasing the energy. When you jump on a trampoline, the surface stretches. This stretching stores elastic potential energy, which is then converted back to kinetic energy, propelling you upwards. Drawing a bow stores elastic potential energy in the stretched bowstring. Releasing the string converts the stored energy into kinetic energy, propelling the arrow forward. The amount of elastic potential energy stored in an elastic object like a spring can be calculated using the following formula. EPE equals half KE squared, where EPE is the elastic potential energy, K is the spring constant, a measure of the stiffness of the spring, and E is the extension or compression of the spring from its equilibrium position. We will explore this equation further in the next lesson. In today's lesson, we delved into the concept of elastic potential energy and its significance in the context of physics. We learned that elastic potential energy is the energy stored in objects when they are stretched or compressed, poised to be converted into kinetic energy for movement. This concept helps us understand how everyday objects like springs, trampolines, and bows can store and release energy efficiently. We also briefly mentioned how we calculate elastic potential energy, which we will delve into further in the upcoming lesson. Recognizing and calculating elastic potential energy is crucial in both understanding and engineering, a range of mechanisms and devices in physics and beyond.